Now another asymmetric algorithm you need to know about is Gamal. It's not one that's used as much as like RSA, but it is out there, and it also is based on calculating discrete logarithms in a finite field. So just like Diffie-Hellman. Now Gamal can do the same types of functions that RSA can do, which is digital signatures, encryption, and key exchange. And when we say key exchange, you could send your public key to somebody, and they can use that public key to encrypt the symmetric key that needs to come back to you. Now another algorithm that's a little bit newer is called ECC, Elliptical Curve Crypto System. And what makes ECC different than the other asymmetric algorithms is it uses a different type of mathematics that's not as complex as the other asymmetric algorithms. And basically, we're not going to go through exactly the mathematics, but basically on elliptical curves, it takes points and uses those in its mathematic equations to do the encryption. Now, since the ECC mathematics are more simplistic than the other asymmetric algorithms, it doesn't take as much processing power. So ECC is commonly used in resources that don't have a lot of processing power, a lot of memory, like our PDAs or our phones that could do encryption. So ECC is commonly used in those types of devices because it doesn't require as much processing. Now, another thing with ECC is that a smaller key than like an RSA key can provide the same amount of protection. So the smaller key size in ECC, when you map them together, so let's say the ECC, you have a key size of 320 bits. Now, the level of protection that provides, the RSA key would have to be 5,120 bits. And so not only does it work faster, but it provides more protection, or it doesn't provide more protection. It's just that you don't have to have as large of a key to provide the same amount of protection that other asymmetric keys provide.